Good morning. Welcome to the South African National Space Agency, our Hermanus campus this morning. My name is Leanne McKinnell. I am the Managing Director responsible for the Space Science Program in SANSA and also for this facility, the Hermanus facility. And it gives me great pleasure to welcome you here this morning. I just want to let you know that we are streaming live to our YouTube channel because there were a number of people who were not able to make it. So I will be spending quite a lot of time behind this big box so that everybody could hear me, because IT have told me it's much more important for people to hear me than to see me. So I can hide behind the box. Thank you very much for taking the time out to join us. I know that this is, for many of you, this is a new area, new subject, maybe a little bit different, and I'm really glad that you felt it worthwhile exploring a new topic and coming to spend today with us, and we will do our best to meet your expectations. So we've aimed our presentation and our day today at the agricultural, maritime and mining sectors, and of course probably we should aim it at the energy sector too. In 30 seconds the lights will go back on, so don't worry. Should I hang on a minute, Gareth? You can hear, so that's fine. Yeah, and as I said earlier, you need to see me, right? Okay, so we've aimed it at mostly at those three sectors, but what we really want to do is start a conversation around what is important for people operating in those sectors and where SANSA can play a role, particularly in the fields of magnetic technology and space weather. So today I will cover just a brief introduction to the Space Agency and the Hermanus campus. Then I'll talk a little bit about magnetic technology, a little bit about space weather, and then most importantly, of course, the impact on agriculture, maritime, mining sectors from our point of view. And then we will then go back into the foyer behind me, where we will have a demonstration, space weather demonstration, and then we're going to take a wet walk to the magnetically clean area where we're going to have a magnetic technology demonstration as well. And after that there'll be some time to network with the SANSA people. So I mentioned that I'm from the that I'm Managing Director responsible for space science. We also have colleagues from our Earth observation unit with us today, and so there is a number of SANSA people available to answer any questions that you may have. So, introduction to SANSA and SANSA Hermanus. So the South African National Space Agency was established on the 1st of April 2011. We are a Schedule 3A public entity, for those of you who know your Public Finance Management Act, and we report into the Department of Science and Innovation. And that department falls under the Minister of Higher Education, Science and Innovation. So, so if you want to say it in a hurry, South African National Space Agency, depending to the Department of Science and Innovation, reporting to the Minister of Higher Education, Science and Innovation. And if you can say that in a hurry after you've had a glass of wine, you're doing really, really well. But that's how we fit into the public space. Our mandate is informed by several pieces of legislation, policy and strategy, and you'll be very pleased to hear that I'm not going to take you through all of those today, except that to say that most people are not aware that South Africa has a National Space Agency Act that gave rise to SANSA, but we also have a Space Affairs Act, and we have a National Space Policy. And so what we do is governed around that. Our mandate is governed around that. And just as a sideline, the African continent also has a space policy and a space strategy that South Africa participated quite broadly in setting up. The space industry on the African continent is now growing considerably, and in fact, as of today, we have 19 space agencies in operation on the African continent, which is like a trivial pursuit question that you might get asked someday. Okay. SANSA operates from 5 different programs. Administration, which takes care of our HR, finance, procurement needs, and then we have operating units in Earth observation, space science, space operations, and space engineering. We have 3 campuses in South Africa. So we have a campus in Pretoria. Pretoria is where our head office is located, so our CEO is based there. Our Earth Observation Division is largely based there as well. We have a campus at Hartbeespoort, which is 100 kilometers west of Pretoria, and that is the campus where we run our space operations program, and we do mostly tracking, telemetry, and control of satellites. And then we have our Hermanus campus down here in the Western Cape, 120 kilometers from Cape Town. And although you might not think so today after having battled the rain to get here, but it is the most beautiful campus we have in SANSA. So what is the role and function of the Hermanus facility? We are responsible for the space science program within SANSA, which basically means that we do fundamental and applied space science research. So we operate in the near-Earth space environment, which means everything from the sun to the Earth and its impact on Earth. We have a very strong and credible research program operating in this area, and we also provide a science and applications data platform through a distributed network of geophysical instruments. And what that means is that we are very good at measuring space from the ground. With the credible research program, as well as an extensive data platform, we are able to then provide space weather applications, products and services, and magnetic technology products and services, which are the 2 areas of our business that I'm going to share with you today. This facility here in Hermanus is also responsible for SANSA's postgraduate science student training and other skills development, as well as has a vibrant science engagement program and a science center. And I believe that there may be an opportunity a bit later for you to visit the science center if you would like to. This facility was established in 1940 in Hermanus, so we've been operating for more than 80 years from this very location in Hermanus, and that's a fact that most people don't know. So we have a very long database of magnetic observations. The facility was set up as a magnetic observatory initially. It was known as the Hermanus Magnetic Observatory, and it migrated to SANSA in April 2011. We sit on 16 hectares of land in the Westcliff suburb of Hermanus, and one of the reasons we're here is because we have a defined magnetically clean environment here, which means that we are not influenced by external magnetic forces, and that means that there's a number of products and services that are unique that you can get here that you can't get anywhere else, and I'll explain a bit about that a bit later. We currently have 80 employees based in Hermanus. SANSA's employee complement is 210, so roughly a third of the employee base is based here in Hermanus and lives and works here. We also have about 20 additional people at any one stage on the campus. That will be students, visitors, etc. We host between 10 and 20 international visitors per year. We run at least 1 international conference or workshop per year and 2 student schools per year. We have an international designation as a regional center for space weather information provision, and I'll talk a bit more about that later. And then our distributed geophysical instrumentation network consists of approximately 14 measuring stations around Southern Africa, Antarctica, and the islands. We were also recently ISO 9001 certified, so everything that comes from this facility has an ISO certification. I mentioned that we started life as a magnetic observatory, so we started taking magnetic observations in Hermanus on the 1st of January 1941. So this whole facility is operated on magnetic observatory principles, which means that everything that we build, every activity that we do, we take into account the impact that we're going to have on the background magnetic field. A lot of people ask me the question, well, why is Hermanus magnetically clean and why did you move here? So prior to 1941, the Magnetic Observatory was set up in Cape Town at the University of Cape Town. But in the 1930s, the South African Railway Company was growing and they were electrifying. And one of your biggest influences on your measurements of the Earth's magnetic field is the induced magnetic field that comes from an electric railway line. So you want to be as far away as possible from any railway electric electrification of railway lines. So at the time, and I now believe that the story is true. For years I used to say, I don't know if it's true or not. The then chairman of the South African Railway Company, Sir William Hoy, had a holiday home in Hermanus. He said when he comes on holiday, his workers won't come with him, so he could almost guarantee us there wouldn't be any electric railway line to Hermanus. We do have a railway station though, but it's been turned into a shopping centre. We are a member of the International Network of Magnetic Observatories, which means that the data that we collect is of a certain quality, and you can get that quality data and that latency of data anywhere when you come across one of those magnetic observatories. We have 4 magnetic observatories, including Hermanus, that belong to the intermagnet community. This Hermanus, the Hermanus Magnetic Observatory, though, has the longest database of magnetic observations in the world, and it's also one of only 4 global magnetic observatories whose data is utilized to calculate a global disturbance index that is utilized to characterize the magnetic field at any point on the globe. And that disturbance index is called the DST index. Sorry, not the government department, the magnetic index now. DST index, and it is utilized in every space weather model in the world at the moment, utilizes the DST index. So you could say that Hermanus is contributing to every single space weather model that has been developed in the world. So we have a very rich legacy here. We have 80 years of magnetic observations, we have a magnetically clean environment, we have a strong space science research program, we have geomagnetism expertise, high quality geophysical database, and we have very strong scientific credibility. And what this means is that we are able to provide a foundation and to lead on the African continent in magnetic technology and space weather applications. And we're hoping that you will agree with us that we have a lot to offer by the time we get to the end of our program today. So I want to talk a little bit about magnetic technology first. What do we mean by magnetic technology? So we have this very unique environment, this magnetic clean environment that I spoke about. We also have a number of experts in geomagnetism, and this allows us to provide unique products and services to clients. And I'm going to give you a list of those unique products and services in a moment. So for example, landing compasses. So we're able to calibrate and maintain landing compasses. Now your landing compass is not the compass that sits on the aircraft and gives the aircraft direction. It's the compass that sits at the aerodrome or the airport that the compass on the aircraft is calibrated against. So, and the Civil Aviation Authority says that all landing compasses have to be calibrated at least once per year, and you need very specialized equipment to do that. And we are the only place in Southern Africa where you can get your landing compass calibrated. We do a lot of work for the aviation sector in terms of magnetic technology. So we are an aviation training academy, especially for the South African Air Force, and we provide training courses such as aircraft compass swing procedures and also magnetic awareness courses. We are also able to provide geomagnetic data and field modeling expertise, and what this means is that when you go to mappings and you want to get one of those big large-scale maps so that you can use them for your applications, those maps are built on magnetic inclination and declination points, and those magnetic inclination and declination points are obtained from this facility on a 6-monthly basis. And they're updated every 6 months because the Earth's magnetic field is changing constantly, and so you need to have a rapidly changing geomagnetic field model as well. And then we do everything to do with magnetic navigation. So we will source and integrate magnetic sensors on board platforms such as unmanned aircraft, satellites, as well as characterize those platforms to ensure that the magnetic sensors give the most accurate possible reading. And we can do that because of the environment that we're in. This is just an example of what I was saying in terms of the Earth's magnetic field. If you look at the diagram on the left-hand side, you will see our 4 permanent magnetic observation stations with the data feed from each of them. Hermanus being the longest one, and you will see that the Earth's magnetic field is decreasing over time. Not enough for us to be worried about in our lifetime, so please don't fear, but it does mean that we have to continuously update the magnetic inclination, declination maps and magnetic variations at certain locations. And so this work is utilized to provide accurate mapping for beacons, for airports, for ships, for surveillance, etc. We are also in the process of setting up a magnetic standard, so essentially it'll be like 1 Tesla in a bottle. We have acquired a Barker solenoid which was built specifically for us, as well as a very sensitive nulling magnetometer and current source, and we are currently in the process of applying for designation as a calibration facility for South Africa and the holder of the South African magnetic standard, which means that if you need something, anything calibrated to a magnetic standard, this will be your place to come. Right, then a little bit about space weather. So I mentioned that we are experts in the near-Earth space environment, and space weather is one of those things that has become a global challenge. Similar to climate change, it's now been announced as a global challenge, and South Africa, I'm very proud to say, has been part of the forefront of getting an operational capability in space weather. If you look at the picture on the left-hand side, that is what we refer to as the near-Earth space environment, where the environment between the sun and the Earth and its impact on Earth. So we're not only interested in what's happening in space, but we're interested particularly in the impact that is going to have on Earth and on our technological systems. I have a short video I want to show you because it's much easier for me to explain in a short presentation with a 4-minute video what is space weather and how we are developing our capability, and you'll see in the next couple of sections of my presentation I'll use a couple of videos to emphasize the points, and just bear with me and hopefully you will enjoy it as well.
Why is it important? What is the threat? What is the impact on technology? How does it differ from terrestrial weather? What is space weather? The Earth, our home, orbits our life-giving star called the Sun. The Sun is not only extremely hot, with a surface temperature of about 6,000 degrees Celsius, but it also has certain activities happening on its surface, like solar flares, coronal mass ejections, storms, and heat, basically emitting millions of particles, radiation, and energy into space. This causes space weather. And even though the Sun is about 150 million kilometers away from Earth, our planet can still be affected by space weather. Just like Earth's weather has seasons, space weather has seasons too. The Sun has a cycle of about 11 years, known as solar minimum with low solar activity and solar maximum with high solar activity. But even during times of low solar activity, solar storms and solar flares may occur. Solar flares are giant explosions on the surface of the Sun that occur when twisted magnetic field lines suddenly snap and release massive amounts of electromagnetic energy. A solar flare takes about 8 minutes to reach Earth and travels at the speed of light. Charged particles reach the Earth, while mass ejections, which is a large cloud of charged particles, will take 1 to 4 days to reach the Earth. When the magnetic field of a coronal mass ejection interacts with the Earth's magnetic field, it causes a temporary disturbance known as a geomagnetic storm. Space weather is constantly interacting with our Earth's magnetic field, but the impact of a space weather storm will not harm humans and other life forms on Earth, as we are protected by the Earth's magnetic field. The Earth is a giant magnet, and the field it generates acts like a shield against solar particles and radiation. However, our astronauts, the aviation sector, and satellites are at risk. If satellites are hit by space weather, radio communications, telecommunications, navigation and weather services may be affected, and many more electronics can suffer hardware errors and failures. This can disturb internet connectivity, have an effect on your cell phone, interrupt satellite TV, and even cause radio blackouts. In severe cases, the power grid may be damaged. Astronauts also have to be aware of space weather and should avoid spacewalks during space weather events in order to avoid the radiation from the sun. Passengers and crew on long-haul flights can also be exposed to radiation during space weather events, which is why the International Civil Aviation Organization recommends that space weather information be included into flight plans. But the effects of space weather interacting with our magnetic field can also be spectacular. The magical lights in the sky called aurora are an effect of space weather storms such as solar wind, solar energetic particles, and coronal mass ejections. And while we enjoy the beautiful views from our balconies, looking up into the sky, we can remember that our magnetic field is working non-stop to keep our planet safe. Scientists from around the world are constantly monitoring the sun and our magnetic field to predict space weather and warn of their effects. The South African National Space Agency is expanding to do this on a 24/7 basis and offers several products and services to mitigate the effects that space weather may have. The advancement of space-based technology has brought about many benefits to our society. It helps us to communicate, to find our way, and to predict adverse weather conditions. It even helps us to plan our cities and towns. So what would happen if all our satellites stop working? It's unlikely that all our space-based technology will go out all at once. But a big space weather event could damage our satellites and ground infrastructure and cause issues with daily tasks. We rely on satellites for air traffic communications and weather prediction. We rely on satellites for navigation. Power grids are vulnerable to the onslaught of continuous space weather events. Modern farming methods are increasingly reliant on space-based technology for sowing, crop care, and harvesting support. We rely on satellites to provide time synchronization that allow for international money transfers and ATM banking. Space-based technologies are a catalyst for development, innovation, and creating a better life for all on this Earth. It is thus important to protect these technologies against threats such as space weather, which can harm technology and impact our daily lives. At the South African National Space Agency, we work around the clock to create products and services that will help mitigate the effects of space weather to our technologies to secure a better future for South Africans and the continent.
These are interesting times. A time where cars drive themselves.
What could go wrong?
Companies are racing, and tech giants, they're rushing to be first.
Nice crowd.
Not everyone seems to be agreeing with the global climate agreement.
What could go wrong?
Your smart house is controlled by your smart device.
What could go wrong?
And deliveries, well, they're getting smarter too.
What could go wrong?
What we sent up there is starting to come down here. We're building higher and higher and even higher up. And we're moving further out. It's the age of invention, of artificial intelligence. What could go wrong? When things go wrong, wouldn't you want to be with the insurer that makes it right?